Hello and welcome to the Let's Learn project. If today is the first time that you are joining us, kindly subscribe to our YouTube channel. You can also visit our website, the Let's Learn project, for all of your lessons. Today we are looking at binary operations. My name is Anoff Akonnor and I'll be your instructor. Alright, so we'll be looking at the binary operations, what they are, their definition, and then we'll take a look at some examples regarding binary operations. A binary operation is an operation that combines two elements in a set to produce another element. So think of addition, the usual operations that we know in mathematics. Addition, multiplication, subtraction, and then division. These operators are called binary operators because they combine two elements or two terms always to be able to produce another term. So the reason why we call them binary operators is because these operators always operate on two terms. Okay, binary. Anytime you hear bi, it means we are talking about two things. So binary operation. We are using an operation on two items or two terms to produce or generate a new number or a new item or a new element inside of that particular set that has been given. So the numbers or the items or the elements in that particular set that the binary operators are operated on are usually called operands. They are called operands, and then the particular binary operator is just the operator. So for instance, when we have 7 plus 8, the 7 and the 8 are called operands, and then the addition that we have here is the operator. As mentioned, addition, subtraction, multiplication, and division, they are just ideas. Anytime that you see addition, what it tells you is that add the two terms. Anytime you see subtraction, what it is telling you is that subtract the term on the right from the term on the left. So these are ideas. So the operators are just ideas that have been introduced into mathematics. So that anytime you see the sign or the symbol, then you perform some particular action. We are saying this because these are not the only operators that we have in mathematics. So aside these, in binary operation, we have some custom binary operators. A few has been listed here for you. We have the star, we have nabla, we have delta, then the rest as stated here. But to be able to use a binary operator, it has to be defined first. So before any binary operator is given to you to use as your operator, you need to be able to define that binary operator first. So for instance, in this binary operator we have x star y. So the x and the y are operands here, and the rule, the definition is the rule that has been given here. It says that anytime you see x star y, you have to do this. You multiply 2 by the x, then you add it to the product of 3 and y, then you subtract the product of x and y from whatever that you have. So anytime you see x star y, you do 2 times of x plus 3 times of y, then you subtract xy from it. So this is the definition or the rule that came with this particular binary operator, and this is usually how they are stated in exams. But if a binary operation is defined as this, then do that. So let's look at a few examples with regards to binary operation and see how questions under these are solved. So a binary operation is defined by x star y equals 2x plus xy. We are to find 2 star 3. So first, we state the rule that has been given. Then we have to find 2 star 3. So we are only doing substitution. The assigned value to x is 2 here, then the assigned value to y is 3 here. So wherever I see x and y, I put in 2 and 3 respectively. So the blue is for the x, then the red is for the y. So that is what has been done there. 2 times x is 2 times 2, then xy is 2 times 3. When you perform this correctly, your answer is going to be 10. Let's look at another example. A binary operation delta is defined by a delta b equals a plus b all over the root of a times b. So this two we have to evaluate -1 delta, -2. So similarly, we first state our rule, that is a delta b equals a plus b all divided by the root of the product of a and b. Then we just do substitution. The assigned value to a is -1, then the assigned value to b is -2. So we just substitute. Where we see a, we put -1 there. Where we see b, we put -2 there. When you simplify this, at the top we have -1 plus -2. That gives us -3. And at the bottom, the root of -1 times -2. -1 times -2 is 2. So at the bottom we are going to have the root of 2. And then the denominator is an irrational number. So we have to rationalize it. That is, the root 2 we use the root 2 to express 1. When you multiply 1 by any number, you haven't done anything to the number. So at the top, we have -3 times root 2, and that is -3 root 2. And at the bottom, -2 times root 2 is going to give us -root 2 squared. And then the square will cancel the radical symbol, so that your final answer is going to be -3 over 2 root 2. Let's look at another example. I want to do this with you. Alright, so let's solve this question together. We have a star b equals a plus 2b all over 3. So first we state our rule, the rule that has been given. It says that a star b, whenever we see a star b, we have to do this. A plus 2b all divided by 3. So anytime we see star combining 2 elements, we have to do this. And then they are saying that we should find m if 3 star m star 4 is equal to 3. So we have 3 star bracket m star 4 is equal to 3. We know that anytime we have any equation or any expression, what we do is what is in the brackets first. We are following Bodmer's. So we have to do what is in the brackets first, that is m star 4, using the same rule or the same definition that has been given. So m star 4 will be, now this is the a and this is your b. So we have m plus 2 times 4, that is our b, divided by 3. So let's simplify this further. Then it means you have m plus 8 all divided by 3. Remember, this was what was inside of this bracket, so it means we can put this expression here inside of the bracket, so that we have 3 star into bracket m plus 8 over 3, and they said everything is equal to 3. So this is what we are doing. That is what we are doing. So now the binary operator is still here. It means this is our A now, and the whole of this is our B. So we just do the substitution again. So our A is what? 3, then plus 2 times our B is now M plus 8 over 3. And then they said everything should be divided by 3. When we have that, then it is equal to 3 again. So that is what we have here. Let's simplify further. So I can see 3 at the bottom here. Since it is dividing here, I can just multiply both sides by 3. If I multiply both sides by 3, this 3 will cancel out, and then there will be a 3 being multiplied here. So this is what I mean. So I have 3 plus 2 bracket M plus 8 all over 3 is equal to, now when the 3 multiplies this 3, we are going to get 9 here. Alright, so now you can see 3 here again, so this 3 can come to the right hand side. Now remember, this 2 here is multiplying the whole of this, so we can do our multiplication there. That is 2m plus 8 all over 3, and then we are bringing this 3 to the right hand side, so we have 9 minus 3. We are able to do this because this 2 is assumed to be 2 over 1. So we are multiplying the numerators, then we are multiplying the denominators. 2 times n plus 8, then 1 times 3. And then this 3 is coming to the right hand side, so that we have 9. It is positive here. When it comes here, it becomes negative. So now, if I'm simplifying what's at the top, I'm going to get 2m plus 2 times 8 is 16 divided by 3 is equal to 9 minus 3 is 6. If I'm simplifying this further, I'm getting 2m plus 16. Now this 3 is dividing here. When it comes here, it will come and multiply. So 3 times 6, that is 18. And if I'm grouping like terms, I have 2m equals 18 minus 16. So I have 2m equals 2. Then if I'm dividing both sides by 2, my m is going to be 1. Alright, so this is what we get for this particular question. You can pause the video to go over what we've done, or you can go back a little to rewatch it again. Let's look at another example. It says that a binary operation is defined on a set of real numbers, on a set of positive real numbers by p star q equals 2p plus 2 over q minus pq. And we are to find, and if 2 star x is equal to 4, we are supposed to find x. So it's similar to the question that we just did. So let's look at that. Let's quickly look at that. So remember that we said that we always state our rule first. So our rule is that p star q equals 2p plus 2 over q minus pq. So that is the rule that has been given to us. P star q equals 2p plus 2 over q minus pq. And they are saying that 2 star x is equal to 4. If 2 star x is equal to 4, it means we have to express this in terms of the operation that has been given. So my p is 2 and my Q is x. So this implies that we have 2. Remember, my P is 2. So 2 times 2 plus my Q is x. So 2 over x minus my P is 2 and my Q is x. And the whole of this. So we have expressed 2 star x in terms of this, and it said it is equal to 4. So we have to write it. Everything here is equal to 4, just as they have given it to us. Now let's simplify this further. So 2 times 2 is 4 plus 2 over x minus 2x equals 4. Now we see that there is 4 here, there is 4 here, so they can even go out. They can cancel each other, so that we have 2 over x minus 2x equals 4 minus 4 becomes 0. Then, since this is a denominator, we can multiply each of the terms by the denominator, so that we have x multiplied by this is giving us 2. Then x coming to multiply 2x, we're going to get 2x squared is equal to 0. Alright, so now we have 2 minus 2x squared is equal to 0. Since this is 2x squared, it means we can bring the 2 here, so that we have minus 2x squared equals minus 2. And since the negatives are here, they will just cancel out, so that we have x squared equals 1. Remember, we are just looking for x. It is not x squared that we are looking for. So it means we have to take the square root of both sides. And if I take the square root of both sides, the left hand side I'm going to get x equals, then the right hand side I'm going to get plus or minus the square root of 1. And plus or minus the square root of 1 is going to be 1 or negative 1. But remember, the question said that the binary operator is defined on what? The set of positive real numbers. Since negative 1 is not a positive number, it implies that. So you can say that therefore x is equal to 1, since we are looking at positive real numbers. Alright, so let's look at another example. This question says that a binary operation star is defined on a set Z of integers by x star y equals 2x minus xy plus y squared. Evaluate 5 star negative 2. So remember, we always have to state the definition that they've given to us in the binary operator. And this one says that x star y equals 2x minus xy plus y squared. We have to evaluate 5 star negative 2. It means my assigned value to x is 5 and that of y is negative 2. So all that we do is our substitution. So my assigned value for x is 5, then minus my assigned value for x is 5 and y is negative 2, then my assigned value for y is negative 2, so negative 2 squared. Let's simplify further. 2 times 5 is 10. Negative 5 times negative 2 will give us positive 10. Then plus Negative 2 squared is 4. So when you do this, you're going to get 10 plus 10, that is 20, plus 4, that is 24. So this becomes our answer for this particular question. When you get here, you have to take your time. The 5 here now has become negative because of this sign. We have minus here. Our x is 5. Your y is negative 2. They are multiplying. Because your 5 is here, it becomes negative 5. So negative 5 times negative 2, that becomes positive 10. Then negative 2 squared is negative 2 times negative 2, so that is 4. And when you do that, your answer is going to be 24. Alright, so I've tried to get you some questions to try your hands on. So the first one is a binary operation star is defined on the set R of real numbers by A star B equals A squared plus B minus 4AB. Evaluate 2 star negative 3. Then the second one is with 2 star with 3, and your binary operation has been defined there for you. The second one looks like the first two questions that we solved. So you perform the operation as has been defined, and then you find the value for x. And then on the right hand side, you have a few questions that I've given to you. What are binary operations? In your own words, try to define what binary operations are, and then give 4 examples of binary operations. I know you can do it quite simply. And then on the internet, try to research on the importance of binary operations, not just in mathematics, but in the world. Alright, you can visit the letslearnproject.com. The questions that we have here, I'll do my best to solve them in a video form on the website. So if you can visit our website, you get to know how these questions can be solved. Alright, thank you very much for watching this video and for learning. If you haven't subscribed, kindly consider subscribing and share our videos to other students to help them learn. See you in another video. Goodbye.